Welcome to Precalculus Concept 36A underneath additional topics in trig. We're going to talk about polar coordinates today, and there are 5 boxes. So let's begin with box number 1. So we are used to the coordinate system on the left-hand side there, which is known as the rectangular coordinate system. And just as a quick little brief remembrance, a rectangular coordinate system has a point called the origin, and I could have like a point somewhere over here in the plane, and we would label this point as an x coordinate of a 6 and maybe a y coordinate as a 3. So we would label an x and a y in the rectangular coordinate system. And this is something that we are super used to and makes a whole lot of sense to us. Now, on the right-hand side, we have what's known as a polar coordinate system, and you'll notice that it kind of looks like a unit circle. But notice that each tick mark in this particular graph is worth a pi over 12, not a pi over 6, like we've seen on the unit circle. But in any aspect, the difference here in the polar coordinate system is that instead of the point over here known as the origin, we have the point in the middle here that's known as the pole, P-O-L-E, the pole. Okay, and instead of like an x-axis and a y-axis, we only have one axis, which is sort of glued down over here on the right-hand side, which is called the polar axis. Polar axis. Okay, and if I want to talk about sort of moving this polar axis around the pole, let's say I wanted to talk about, like moving this thing to here, then I have sort of swept out an angle that is worth 5 pi over 12, because it says so right there at 5 pi over 12. And the distance that I have gone, which is this part right here, all the way that I've swept out, is what we're going to call r, a radius. So if I wanted to say, more specifically, if I want to talk about just this point right here, the one that I'm like making a big orange dot on, I would label this with 2 elements. And those 2 elements would be an r and a theta. Okay, so in this particular case, the r would be a value of 1, 2, 3, 4. It would be 4 units away from the pole, and it would be swept up at an angle of 5 pi over 12 on the polar axis. So instead of an x and a y in the rectangular coordinate system, we have an r and a theta in the polar coordinate system, but everything else pretty much stays the same. Okay, in box number 2, I'm going to show you how to plot points in a polar coordinate system. Remember, a polar coordinate system is all based on the fact that we're given an r and a theta. So let's consider point A first that I just drew a box around. It says 2, 135. Well, 2 represents the radius, and 135 represents the theta. So the way that you graph these is by doing the angle degree measure first, and I'll tell you why in a second. 135 degrees is the same thing as 3 pi over 4. So I'm going to identify 3 pi over 4 on the pole, and then on the polar axis, and then I'm going to go out 2 units from the pole. So if here's the pole, I'm going to count 1, 2, and that right there is going to be point A, and that point is at 2, 135. That one's not so bad. So I identify the angle first, and then I go a radius of 2 units out from the pole and put point A. I'll switch colors for you here. I'll do purple, and let's do point B. Point B says 3, 3 pi over 2. So again, I'm gonna find the angle first, 3 pi over 2, and from the pole, I'm gonna go 3 units in that direction. So 1, 2, 3. So this point down here is what we're gonna label as point B. Okay, now here's where it gets a little bit tricky. All right, C is -1, negative pi over 4. So again, I'm gonna identify the angle. And remember, a negative angle is going to swing clockwise, so I'm going to swing down to negative pi over 4. So that would be this point right here at 7 pi over 4. And then normally, right, if I was going to draw this as a regular sort of standard angle here, I would have this business going on. And that would be the positive angle, and this would be negative pi over 4. So that's how I got that. But where do we put the point? Because it says -1. So what we do is we draw an imaginary axis in the opposite direction. Am I on this pole here? In the opposite direction, and we go that many units on the pole that is opposite the way that it lands on the first part. So what I mean by that is I would go back 1 unit from pi over 4, and I believe this is my point here. Oh, this would be green, sorry. So this would be my point here. So this would be the point C, and it would be at negative pi over 4 and then negative 1. So I go negative pi over 4, and instead of going on the polar axis that it lies, because my r is negative, I go in the opposite direction and put the point there. Kind of a funky thing to think about. Okay, and lastly, let's go to point D here, which is going to be pi and negative 2. So same difference, so let's go to pi. So here's my pi, and normally I would draw, this is my radius out this way, but instead, because my r is negative, I'm going to go 2 units in the opposite direction, and that's going to be point D right there. Hopefully that made sense to you. Okay, here's a quick you try. Which of the following points is located at negative 5, comma, pi over 12? Now, take special note that r is negative. So point F was the correct answer. Hopefully you got it correct. The reason that point F is the correct answer is because first I'm identify pi over 12, and then I would draw my normal polar axis, but then I would go back up 5 units because my r is negative, and I would end up right here 5 units away in the opposite direction along pi over 12 at point F. Okay, in box number 4, I want to talk about the many multiple ways of representing a point in the polar coordinate system. So because we can just go around and around and around the circle so many times, we can really identify a point in a number of ways. So here's the example I'm going to give you, okay? We're going to take the point 2 comma pi over 3, and we've got that point highlighted for you right here at 2 comma pi over 3 in the polar coordinate system. We're going to represent this point 3 different ways. The first way that we're going to do it is with the constraint that we want r to be greater than 0, but we want the angle to be somewhere between 2 pi and 4 pi. Well, that's pretty straightforward. Then all that we would do is we would go around, if I drew an angle here, I would go around there, and then I would just simply go around again. And that would put me at, I would have the point 2 comma pi over 3 plus another 2 pi, which would give me 7 pi over 3. So therefore, the point 2 comma 7 pi over 3 is another way to represent it. And number 2, if I want r to be less than 0, but I want my angle to be positive, okay, then all we got to do is to represent this point, think about how I can get to this point. Remember, if I wanted to go, if I want my angle to be positive, then I could go, I'll draw this in red for you. If I drew this all the way back here, this line here, this negative pole, if I went all the way around to that angle, which is 4 pi over 3, and then backed up negative 2, I would end up in the same spot. So I would go all the way around to 4 pi over 3, or sorry, negative 2 comma 4 pi over 3. So that value matches the constraint that r is negative, but yet I still ended up in the same spot at 2 comma pi over 3. So that's another way I can do it. And then finally, if I want my r value to be positive, but I want my angle to be somewhere between negative 2 pi and 0, okay, then all I can think about is going, I'll do this in like purple for you, then I can think about going this way, in this direction. So if I went in that direction, it would be 2 pi minus pi over 3, and then that would give me negative 5 pi over 3. So I could do 2 comma negative 5 pi over 3, I just did pi over 3 minus 2 pi, and that meets the constraint that my angle should be between negative 2 pi and 0, and my r value is still greater than 0. So there are a whole lot of ways that we can represent a single point in the polar coordinate system. Okay, last box is a you try. I graphed the point for you at 5 comma pi over 4, and I want you to come up with a new representation under the following constraints. I want your r value to be negative, but I want your angle to still be positive. Okay, so the right answer is negative 5 comma 5 pi over 4. So how did I get that? Well, I looked at the graph and I thought, okay, if this is up here at pi over 4, then this would be my positive direction to that point. So the negative direction would be this angle here, which is 5 pi over 4. So I'm going to go all the way around to 5 pi over 4 and then back up 5 units to make my r value negative and to keep my angle between 0 and 2 pi. Hopefully that makes sense to you guys.